Test. Check. Right. Give me a second here. I just want to get this set up. Do I already have this one? I do already have this one. Let's cancel this. Okay. Oh, good morning. Yes, so I have some people that have joined here. Is the audio okay for you guys? Give me a moment. I was just starting up. I was going to start with the assignment 1 here. Got people online, a couple people local too. So I think that's going to start, hopefully. All right. Let me go and begin. I didn't post an announcement, but I did get back. I did evaluate the assignment 1, so there might be some people. I'm still waiting on some stuff, but I am going to maybe review it a little bit. I don't want to spend too much time on it, but if anybody has any questions about stuff, let me know. I thought I'd spend maybe 5 or 10 minutes. That's what I try to normally do. So. Yeah, I mean, I hope everybody is listening. There's a learning curve getting started with this stuff, but once you've done it once, it should be quite a bit quicker the next time. You'll already have your environment set up, and you'll kind of know the basics and things. So, future assignments are going to be due on like Friday. I usually say Friday by 5 p.m. But yeah, keep that in mind for the next assignment, especially if you were still working on it this weekend or even yesterday on Monday. So. Okay, I'm great. Hopefully the audio and my performance for the live stream will stay good here. I'm still kind of experimenting with those kinds of things, but it looks like things are okay at the moment. So yeah, let me do that. And then as a reminder, I'll get started talking a little bit about our stuff for the next 2 weeks. So the second assignment is posted. I'm trying to get into sort of the workflow. So about every 2 weeks there'll be an assignment, and I'm going to usually I've been trying to clean up the site a little bit, the ordering and schedule of stuff. So you should see that the next 2 units, 3 and 4, are up right now, including the links to the assignment 2, which I updated a little bit and stuff. So I encourage you, to maybe clone that today or, early this week and start looking at it while you're also looking at the resources So yeah, we are looking at we're beginning actual kind of machine learning this week. So and next week with this assignment. So spend a little bit more time on some libraries. So we'll be using Scikit-learn quite a bit. Okay, so that is kind of one of the goals of this class is. I want you to get a little bit of theory, but I also want you to get some of the practical skills. So Scikit-learn basically implements. It's a machine learning library for Python. So all the stuff we talk about, you can actually do those things, those machine learning models in Scikit-learn. Okay, so we'll be using Scikit-learn extensively, so you should learn the basics of it. And then actually next week we're going to start talking about machine learning in general, so classification and regression problems and specific machine learning algorithms and things. So anyway, that's a bit of an overview of our next 2 weeks here. So let me mention a couple things about the assignment. I guess I can't quite mention things about the assignment yet. I'm still setting up here. So I did get back feedback for assignment 1 to everybody. So I should be almost ready to get going here. For the assignments, I kind of showed this in a video. We're up here now finally from my container, I believe. So, if you've got everything up and running correctly, this is kind of what the thing should look like when you're done, when your container's up and running. So you should have the dev container down there, and you should get this message, and you actually have a Jupyter lab running that you can connect to on your local web browser. I think I've mentioned before, I haven't been using the running notebooks in VS Code all that much personally, but you can do it, and I finally took a look at it. So for this assignment, you probably wouldn't have it, but for all the future assignments, we will be installing the needed extensions that you need in the notebook. So the assignment 1, I didn't have those installing automatically. So if you don't have those, if you try to open up a notebook, though, I found out it's relatively easy. It will kind of prompt you. So in VS Code, if you open up a notebook to work with, and I might just try this here, try working with the notebook inside VS Code here. It will kind of detect that you're working with a notebook, and it should kind of give you the option to install the needed extensions, I believe. No? So maybe not until you try and run something. Yeah, so if you try and run a cell, if you don't have those, so starting with assignment 2, it should set those up. But I found it wasn't that tough. If anybody's interested in working with these, there's some advantages also of doing your notebooks inside of VS Code, including it's got the full VS Code editor. That's the main drawback for me for using notebooks inside of the web browser interface is it's really just a basic editor, so you can't do a lot of complicated stuff to format your code and stuff in the cells in the web browser, but you can use the full VS Code editor and all your things in there. So yeah, if you get that, starting with assignment 2, these should already be installed in the container for you, but if you select that, it will put in the extensions that you need in the container. I think the main ones you need are the basic Jupyter one, probably the Jupyter key maps. I don't know if it's necessary to have the slideshow. The renderers, I believe that's needed. That does stuff, maybe matplotlib, but I'm not certain. But anyway, those seem to work as long as you have the ones that it recommends. So. And then the other thing, though, is you do have to specify the kernel to run in your notebook. So we have, Python installed on all these dev containers, including for the assignments. So if it asks for the password, it's asking for that key, so normally when you start up the Jupyter Lab server, you have to find your token in the nohup.out, but I don't recommend doing it this way. because I was having problems. It was in kind of the wrong context, so the relative paths weren't what I was expecting if I try to run it like that. So, but what I do find that works is if you, instead of doing an existing Jupyter server inside of this notebook, if you just use an existing, select a Python environment, and the one, so within the container, we're using Conda for the Python package manager. The base one is right there. So if you just select that one, you probably shouldn't use these. You should use the one from Conda that we installed. This one should have all the should have all the libraries that we need for the class. So Matplotlib and Python and Scikit-learn and everything are in the Conda one. That one seemed to be working for me, right? So when I select that one, we could do like a clear all outputs. Some of these are a little bit different. There's one button that will restart the kernel, clear all the outputs, and rerun the cells. In VS Code, you have to kind of do those as separate steps. So I usually like to make certain everything's running. I usually clear the outputs, restart my kernel, and then run all, so that I get all the cells rerun, and I know the outputs are from what I just ran then. Okay. By the way, so some people were on assignment 1 were the notebooks that were being pushed to GitHub weren't running cleanly. So this is what I mean when I say run cleanly, is that if you restart your kernel and run all, every cell should run 1, 2, 3 from top to the last one. And it does that, so when you push something to GitHub, it runs the notebook, right? So the first thing it checks is that all the cells in the notebook are running, that no cell is failing, okay? That's kind of a basic thing for me to be able to grade and evaluate stuff, that everything that you've got, all the code and stuff that you've entered into your notebook is actually running, as well as the code inside of the source files for your assignment tasks, right? So let me see, hopefully this is actually a solution. I was going to kind of mention a few things about the solution, but hopefully this is working. I think I mentioned it before, both on the Webverse Jupyter Lab or running notebooks in here. I kind of like using the outline. So for each one of these that's a section or a subsection, you should be able to go directly to it in your outline. So here, let me check. Yeah, so it's still running, but it looks like. So like I said, when I run all, I should be able to go all the way down and see that all the cells ran from 1 to 34 in 38 in sequence from top to bottom there. So, all right, so that's always the first. And it's a good idea before you make a commit and push it up that you check that it's actually running cleanly. So. Another thing I was going to mention is the tests are integrated into the GUI runner on VS Code. So this is another quick check you might want to do for these assignments before you push it up. So if you go into VS Code and you've got some tasks working, I should have all the tasks working in this example solution. You can use the test runner. So click on that, and it should detect the tests in the test assignment tasks. So I mean, when I'm doing the tasks one by one, I don't normally do this, but because it does them all in some random order, so it doesn't do them in the order like task 1, task 2, test, and so on. But this is a quick check to see that they're all running, and you're getting all green check marks for all of those. Although, again, the GUI runner is not too bad, because you can, if one assertion in a particular test is failing, you can see which one, and you can go directly to the one that's failing by clicking on that one. So like if this test doesn't have a green check mark, you can go and look at that, okay? And I was going to mention that, so I know people didn't know about this beforehand, but if you should always be aware of whether your tests are running or not when you're doing the tasks for the assignments. If a test is not running, I mean, you can ask me. I can always give hints, of what that test is what the expectation is that it's saying that you need to meet in your code to pass that part of the assignment. But hopefully you can kind of learn to read the code here, right? So all the tests for any task are in the test assignment tasks. Right, so I don't do a lot of comments on these, but so for this first assignment, the test for first real function you had to write, the Fibonacci efficient, were in this test Fibonacci efficient. So it'll always be something like test underscore and then the name of the function that you had to write in your assignment task. All right, and then if you're failing one of these, if you don't get a green check mark on all these, you can go and try and figure out what it's saying. So, for this first task for the assignment, we were basically just testing, that for the base cases 1 and 2, you were returning the result. So we defined the first Fibonacci in our sequence to be 1. I did have one person do that. Normally the Fibonacci sequence is defined as the first and second base case are 1 and 1, and then the third Fibonacci is 2. But you can define it any way that you want. So I could define my first 2 numbers in the sequence to be 100 and 200. And then ask for the sequence after that, So those are just the base cases, right? But yeah, we were just testing 1, 2, and then a few random ones, 3, 4, 10, and 37. Right. We weren't. I wasn't able to test if you wrote an efficient version or used memoization here. I did that by inspection, by hand, right? But this does test that you at least had it correct in terms of getting the right answer for the basic ones, if I called your function, right? So yeah, those are just a couple of things of the environment that I wanted to mention that you might find useful. Whenever I'm creating one of these assignments, before I make a commit, I always first make certain my notebook runs cleanly, every cell, and then secondly, I usually just pop this up and make certain the tests that I expect to be passing right now for what I've implemented are showing green check marks on all that stuff. And then I make my commit and push it up. So, all right. So let's like I said, I didn't want to spend too much time on this, so let me know if anybody even online, if you ask me if you want to have a question or clarify something or discuss something, let me know, or here in class. As everybody should know by now, our tests are in the code you have to write will always be in the file called assignment tasks. So for all these assignments, and the test will always be in the test assignment tasks. So the first one you had to do was write this Fibonacci efficient. I had 1 or 2 people. I only took off some token points, but a couple of people weren't really using memoization. Maybe just 2 people. You can solve. You can find the nth Fibonacci number in a sequence by just running, by doing a simple iteration. So write a loop that calculates the first, second, third, fourth up to that, and that was effectively what 1 or 2 people were doing. Okay, so if you did that, I'll just say make certain that you do kind of read the assignment description. So you do have to implement it the way I might not always be able to test something. But yeah, if there's a certain way that you're supposed to implement an algorithm or a function, you should follow that. So I mostly did that because I wanted to make certain that everybody's familiar with doing recursion. So you still have to do some recursive calls here to implement it the way that was asked for, plus to maybe introduce you to a technique. So I think of memoization as it's kind of like a caching, although I guess maybe it's better. It's really more like a database. So the basic idea for memoization is, if I have a calculation that takes a large amount of time or resources to calculate, but if it's always the same answer for a set of inputs, what you can do for memoization is you keep a database or a cache, and if I've calculated before, I save the result for that particular set of inputs of what the correct answer is. So that I for memoization, should only ever have to calculate, like the 40 Fibonacci number once. Once it's calculated once, it should be in your dictionary, and forever afterwards, you should look it back up, okay? So I just mentioned another kind of little thing is some people did this reversed. So to me, it's usually a good idea to try and minimize the number of returns you have in a function to reduce complexity. So if you said if n is in fibdic and returned it, then you would have done an else and done this calculation, put it in the dictionary, and then have a second return. So to me, it's a little bit cleaner to do it to reverse the logic. So if the n is not in the Fibonacci dictionary, we know that we have to do the calculation. So we do the calculation, which is recursive calls here. That produces the nth Fibonacci number, and then we save that in the dictionary. So after that, after this check, you know that the nth number is in the dictionary. It's been cached now in the dictionary, so I can just look it up. Right? So if it's already in there, this would get skipped over. We wouldn't have to redo the calculation. Right? Anyway, so yeah, I took off maybe a token 2 or 3 points, 4 points, if you were doing a loop or something here, not doing memoization. I had one person actually do a closure here, which was interesting. So they wrote a function inside of this function and called the function. So technically, they weren't doing memoization either for that, because the dictionary was local to this function. So when the function was first entered, the dictionary was initialized to 1 and 2, but so if I asked for the 40th number, it did a similar thing here. It would be efficient, but it was recalculating. So the second time I called the function to look up the 4th Fibonacci number, it would have redone the calculation. Okay. So anyway, so whoever did that was an interesting solution, but it wasn't really memoization. You really need like a global database or a global cache for memoization. So. But if you look at that notebook about functional programming, this week we're going to look at the Scikit-learn framework a little bit. It uses some functional programming concepts. So the idea of a closure, of like a function that you pass to another function, is something that is done a lot in the Scikit-learn framework for various to do various things. So anyway, I thought I'd just mention that. So again, if anybody wants me to talk about anything, let me know. Speak up. I don't think I have a lot to say on the second one. I mean, the most common thing on the second and the third one, I had some people ask about it. I thought I would mention this again in terms of for future assignments. So in this example solution, I'll probably go ahead and post the assignment tasks here in case anybody wants to kind of compare or look at the reference solution I was using. I used this to build the tests that I was asking you guys to pass for each one of these tasks here. So I was doing something similar for T. I was just creating an array of zeros of the particular shape that was needed, both in task 1 and 2. By default, this uses floats. Okay, so some people, right, especially when you get to task 3, the T was really, we were assigning it the index of when the time step of when the value became greater than absolute 2 in the Z calculation here, right? So some people, to me, rightly, now that I think about it, this T really should probably be an array of integers instead of an array of floats, because we are putting integer indexes in there. So if I do this assignment in the future, I'll probably change my test and say that you explicitly have to have an array of ints. But some people were not passing that because they were explicitly putting ints here, or maybe ints in both places. So if you do the tests, if we look at the test for the 2 and 3 here. So for 2, the test is test 2 numpy operations, but we have an explicit thing here where we're expecting that the data type of T's that you create were floats, right? Same thing. I did the same thing in test 3. So that was, some people hit that on there, right? So the general thing is, yeah, you kind of were right. Now that I think about it, ints would have been a better data type for that. But you should write your code to pass the test for the assignment. You can't change. It is forbidden for you to actually modify this test file unless you ask me first, and there's something that's obviously a mistake that we have to fix. But the tests there are really define the expectations for the code, and there's supposed to be hints for you as well about how you're supposed to be doing things, right? So this might not be the way that you think first. The first way you think of doing stuff, it might not always be the best way. I mean, sometimes I change my mind on what would be the best way, but this is just good kind of practice that so this is kind of like a specification or a design document, and you have to pass these tests. You have to write code to pass the specification, right? So you should always think of it that way, and try and figure it out yourself first of all. So if you're failing a test, come in here and look at which one you're failing, and see if you can understand the requirement and figure it out yourself. And I mean, don't spend hours on it though, or days or hours on it. If you're stumped, ask me for a hint or something. If you don't know why a test is failing or what the requirement is that's being asked for, or something. So, okay. So yeah, there was that for the this third one here. So yeah, some people did some things a little bit more complicated, but to me, this is the most straightforward example solution. So you make a copy, you initialize these to basically see an array of all. Some people were initializing this, starting off by initializing it like with this here, and that causes a problem. Your values in t at index 0 aren't quite exactly what's expected if you don't initialize these to all true and do your first time update here. So anyway, so I probably should update my instructions for the initialization here to make this clearer. So in the reference solution, C is initialized to the shape, all of the complex number, the second parameter into this function. M is just initialized to all values of true, so type Boolean, and T is all zeros before we start doing this. And probably it really should be all integers, but all floats in this reference solution. And then most everybody was using the masks, so was using Boolean indexing the way that I suggested. So that's good. This is a good thing to understand is this kind of stuff. So we're doing vectorized operations here using NumPy, right? So we're actually, M is in our tests, and to generate that picture, M was actually a 480 by 320 shaped matrix, right? So the number of values in all these arrays is 480 times 320. So there's a lot of values in there, right? But depending on the mask, only some of the values are affected here. So I was going to say that we're doing a vectorized calculation, so we're potentially doing the square and the addition on all of those 480 times 320 values. But then the mask here is only doing that on the particular ones where the M is true in this vectorized calculation here. So I hope I don't expect people to have used NumPy before, but I hope Okay, so we might have had a little bit of a lag or pause there. I did restart streaming. I hope we'll be a little bit better now. We'll see. Okay, so let me wrap up on the assignment one. Anybody, anything they want to clarify? I mean, I had a couple of people I hadn't quite gotten a kind of a final evaluation on, so I am going to post this assignment task as a reference in case that'll help anybody if you want to go back and kind of compare what you did with this. Most people were fine. I mean, almost everybody, had the gist of things and we're doing good at this point, so, except for a few people. Yeah, but if you were working on this weekend, you might want to keep that in mind for the next assignment. Get started early. Do commit. Yeah, a couple of other things. Do make commits for each task. So commit early and often. So I even had some people had some problems and lost a disk on this. So I mean, one of the reasons why that's a good practice is if your commit is on GitHub, that work is safe. It's backed up. So if you do lose stuff locally, you won't lose too much as long as you are making commits. For the next assignment, there's only 2 tasks, but there's like a couple of subtasks for the task. I'd like you for each one of the subtasks. Basically, each time there's like a test that you have to run. You should, once you get the test passing, you should make a commit and push it up there. So, and trying to use good commit messages as well. So if you look at your evaluations on if you look at your evaluations on GitHub, and let me look at that real quickly here. So hopefully everybody has figured this out by now, the first assignment. But for everybody that I have given feedback for, you should look at your on your repository. Look in the pull requests. There should be a feedback pull request. If you don't have one of those when you start an assignment, let me know. That should be created. So basically, I will usually do a code review. So I'll actually go through your code. Using what files have changed, and give comments specifically on things that could be improved in terms of format or style, or even corrections or suggestions about things that are wrong. But I'll also usually give a final kind of evaluation on here, right? So all the individual feedback you'll find on the feedback pull request for the assignments. Yeah, I'm still having some lag problems for people that are online here, so I'm sorry about that. I'm going to have to continue, maybe see if we can find better settings here, different solutions. So. Okay, let's move on to new stuff here. So let me go ahead and close this. Maybe if I close this, it might help a little bit. So I usually, when I'm done working on something, if I'm working on stuff in a dev container, I use the file close remote connection. That will cleanly stop that running container, that running virtual machine. It'll also stop your Jupyter Lab. So if I was using Jupyter Lab on the web browser, you wouldn't be able to use it in there anymore. Okay, so I think today, so for this week, there's 3 notebooks about exploration and cleaning. So these are all from the chapter 2 of the hands-on machine learning textbook. Okay, if you haven't already, you should at least kind of skim through chapter 1. So chapter 1 is a big overview, a big picture kind of thing of machine learning, right? So it does talk about the basic stuff we'll talk about in this class. But here, chapter 2 that I called Unit 3 here. So we're going over to chapter 2 this week. Is still kind of some big picture stuff. I wanted to start on this and maybe start talking about assignment 2 as well. So in assignment 2, we are going to do a regression and a classification, even though we haven't talked about those yet. But we're going to do the basics of how you use Scikit-learn and also how we use this other library, the stats model, to perform regressions and classifications. Okay? So everything you need should be kind of in this chapter 2 in these example notebooks. Although, we're also using the stats model. That's not in our textbook, so there is a notebook and some links to stuff you can do to kind of figure out the basics of using the stats model library. So let me see. Let me go ahead and open up those notebooks, and we'll talk a little bit about that. I do have lectures already for the stuff I'm going to talk about here today, so I'll just maybe hit a few highlights of some stuff today and Thursday on those, and we'll begin talking about the assignment 2 as well. I probably want to spend some time talking about stats model since we don't really have that in the textbook either. So yeah, if you've already created a container, usually the easiest way to start it back up is to use your remote explorer and just restart your container. So in kind of one click, or you go to the remote explorer and in one click you can go back, right? So you only have to do the clone and the creation of the container once, and then after that, you should be able to just restart a container, or you should be able to reopen a folder and then reopen it in a container. That works as well. So. Yeah, so I already had this created, so it should come up relatively quickly if the container is already created for you. I'm going to go back and I'm going to use the web browser interface for Jupyter Lab here. So, as a reminder, yeah, so I need my token here that was for my running notebook that we just did. All right. So once you're in there, you should be able to find, let's just start with the first one here for Unit 3. Didn't get a chance to review these, so I'm going to avoid rerunning my cells here since I'm still having a little bit of some lag issues on my live stream. This would be a good time to also mention the project for the class as well. So in the project, I do ask you to pick a data set and do some cleaning stuff. So let me, if you haven't seen this yet, I do want to start talking about this probably starting this week and next week a little bit. There is a little bit of information in here. You might want to start thinking about this. So before, pretty soon in the next week or two, I'm going to ask people to pick a data set to use for the final project and kind of start getting started on this and thinking about it. So basically, I think of this project as kind of a more open-ended assignment. So I ask you to find a data set, but then to do some of the stuff that we're going to be learning in this class. So take the data set, do some data exploration of it. So we're talking about a lot of this stuff this week and next week. So explore the data. Once you have a feel for what's in that data set, do a little bit of cleaning. So the ultimate goal is to get the data set, clean it up a little bit, and build some models. So try and build either a classification or a regression model for the data that will be good at predicting some label or feature of it. All right. I'm fine for people to use like Kaggle data sets, or this is another good archive at the University of California. This is another one. I'll see if I can find some others, but I'll ask people to check with that. I'll ask people not to use the same data set in this class, so it'll be kind of a first come, first serve. Also, there's certain ones that are a little bit too simple. So any data set that we use in the class or that's commonly used for examples like the IRIS data set, IRIS or the MNIST data set, I'm not going to allow you to use that. You have to use something that we don't normally use as examples in this class. So I'll talk more about this project here, but that's the basic idea, and that will be due during finals week. Okay, so we will have a test 1 midterm, and we'll have test 2 during the last week of classes, and then like I think on Thursday of the finals week, I'm going to ask you to have your final project turned in so I can grade it on Friday. So, okay. So yeah, the chapter 2 is some of the stuff. It's really, if you're interested in doing like a career in data science or data analytics, this is kind of some important stuff, you know. So it's just an introduction to, but really people that are doing data analytics in academia or in industry, they spend much more of their time doing the stuff that's talked about here. We could really have a whole class just on data exploration and data cleaning. We focus on kind of the step after that. So once you have a good data set, normally you have a goal of modeling it. So building some sort of a model that can predict things. So for unseen data, can predict the class that data's in. But yeah, so the stuff we're talking about here, though, is really data analysts really spend probably 80-90% of their time doing cleaning and exploration and these kinds of tasks here. So if you run this notebook, we're going to be using this housing data set. So these are just some examples of some functions. If you read this into a pandas data frame, some of the most basic things you want to ask for. So this is data exploration. So the most basic things you need to know about a data set are, how many samples you have in the data set, and how many features or how many columns you have. Okay, so pretty much everything that we do in this class, we're going to be formatting our data as a simple two-dimensional table, and the rows in the table represent samples. So different. So different experiments or different samples of data, and then the columns represent different measurements that we did on the data. So we'll usually call the rows are the samples and the columns are the features. Right? So in this housing data set that we use for this week, it's actually got 20,640 samples. So in this data set, it's information about the housing prices in counties in California. So I think the units are what I would call like a county in Texas. I don't know if that's what they call them in Texas, in California or not. So each one of these, so notice there's 10 features. So this has kind of the latitude and longitude. So that's the location of the county or the middle of the county. But it mostly has averages. So the number of houses that were in this county. So in this county, in the fifth sample that we read in here, there was this county only has like 193 households in it, presumably with an average of 2 or 3 people in each one. So with a population of 430, it's a pretty small county, right? And the average value of the house is $269,700, right? Which this data is pretty old, although that's pretty high. So this is near the bay, so this is probably an upper scale kind of place. So that's probably pretty expensive housing here 10 years ago, or actually it's probably a lot older than that. So it might be a lot more expensive now. And some other stuff. Okay. So anyway, the ultimately in this chapter, we're going to be building a model so that we can try and take data like this and be able to predict what the average or this is a median, not a mean, but predict what the median house value is, given attributes like the income, how much the people make in that county, and this other information like whether that county is near the ocean or far away or that kind of stuff, right? So this is a common kind of thing. This is would be very useful. We would like to be able to have models like this, like if we were in real estate or something. Although a more common one would be for a particular house. So instead of the averages for a county, given a particular house and its location at a street and how many bedrooms it has, we might want to make a model that would predict what would be the value of that house or the selling price of the house, right? So we're doing something similar here. Ultimately, this is a regression problem. So this is the first time I've formally talked in this class about regression versus classification. So those will be the two main kinds of things that we do in this class. We're spending most of our time in this class doing what's known as supervised learning. So when we build a model, we're going to give it input, and also one of the inputs will be the target value that we want our model to be able to predict. So if the target value is something like a real valued number, so here it's like whole dollar value amounts, but it can be any, the house value, the median house value could be any value from, we'll see later on what the ranges of this, but probably something like from as low as $10,000 or $20,000 up to millions of dollars as the average, the median house price, right? So it's really a long range. So anytime you have a long range of values, that is going to be a regression problem. Versus next week we'll start talking about classification problems. So those are the simplest is binary classification. So if our label was like if we were trying to build a email spam filter, and the label was that either this email was a spam, yes, or not a spam, no, true or false. So classification, the label is a discrete categorical variable, and the simplest is where you just have two categories. So that's known as binary classification. All right. So those will be the two main kinds of supervised learning that we look at, and we're talking about regression this week here. So the thing we're trying to build a model to predict is a big range of usually real valued numbers. So these are really integer numbers, but you can think of that as effectively any value within that range could be possible that we want to model and predict here. So I think in the next assignment, I mean, the very first things it asks you to do is read in a data set and then do some data exploration. So the simplest stuff to do data exploration using Python is to use pandas and to use some of these basic functions. So we can find out, how many samples and how many features we have, but here we're finding out the values of one particular sample. So the fifth county, actually the sixth, since we start at index 0 here. So this is the county at index 5 has these values, right? But these are all very useful. We're showing some more practice of doing stuff with pandas. So, for example, if I want to find out what the total number of rooms were for the first 5 samples in my data frame, we could do something like that. Use the iloc, right? So this is only getting the total rooms feature among all these features, and then this says give me just the first 5 of those, and so on. But let's go down to. So kind of our first things for cleaning, for exploration and cleaning, this is really our first step for cleaning. So we're beginning to think about preparing the things we'll need in order to build a regression model. So the first thing you need to do is identify what is the feature that's going to be our labels. So in this case, it's going to be, we're going to try to build a model that predicts median house values, right? So normally when we build models using Scikit-learn, we have to have that in a separate vector, so in a separate one-dimensional array with just the labels in there. Right? So here we pulled those out into something we called housing labels. But those are just the median house values. So notice that this is a one-dimensional, so it's a vector, but it should have the same number of samples as we had in the pandas data frame. So we've got 20,640 counties in this data set. Okay, I was just looking at the time here, so we've got about 10 more minutes. I think my goal for today is, well, let's get down and talk a little bit about visualizing some of this stuff. So I'll skip over this. So there's some stuff in here in order to download this file, but once you have this file as a CSV, so most of the assignments we'll do in this class will expect you to start doing the stuff using a pandas data frame, and it'll usually be just in a simple comma separated values file. So I don't know if I've mentioned that before. So in a more realistic setting, we might actually have this in a SQL database, if we have a much bigger data set or something. But simple CSV files are pretty common for relatively small data sets. I mean, this isn't too small. It does have 20,000 samples, but most all the data sets that you want to use for your final project will be in comma separated value files. So you can just use a CSV file usually for the data set you select for your project. So. So yeah, we'd already done that. I can't remember why we repeated some of the stuff, but we'd done all that similar stuff. So looking at the data, some of the stuff you might do that you'll do on assignment 2, you might want to use the info. So the info is useful to give us information about all of the features in our data frame. And this tells you the main thing, well, there's a couple things you can tell from this. So if there's any missing data, you'll find that some of these don't have the full number of samples. So I can tell right away that we've got one of the features, total bedrooms, some of them had NAs, they had missing data in there. That looks like it was the only one, right? So all the others looks like no data is missing because they all have 20,640 non-null values in them. The other one, this is important as well. So things that it can interpret as integers or numbers, it will load as floats. But things it can't really figure out how to interpret will get probably loaded as a default object in a pandas data frame. So these we'll usually have to do something. These are often going to be something like a categorical variable. So these will be like a string, but we might want to convert that into a category. Like usually we want to map those into like integer values. Right. So yeah, that's the next thing that we show here. So one of the things you're asked to do on the assignment 2 is convert some things into categorical variables, right? So if you find you can't convert this, we might first want to start by our exploration of figuring out what values does it has. Okay. So our ocean proximity it's string values, right? This is relatively clean. So in a real data set, you'd probably see maybe some things misspelled, and you see some people didn't have some agreement. So some people might be using a slightly different category. But we've got what? 1, 2, 3, 4. We've got 5 different separate strings here, and these are the counts of each one, right? So if we want to do a classification, well, I shouldn't jump to that. So here, if we want to use this to build a model with, we can't pass strings in usually to libraries for models that we want to build, so we have to convert this into numbers, right? So we will usually represent categorical variables as like a number. So we might assign oceans to be represented in less than 1 mile from the ocean as like a 1. This is a 2, 3, or 4. We also might use one-hot encoding. That's talked about in this or the next notebook. I'll talk about that in more detail later on, probably maybe on Thursday a little bit. Another useful function is the overall describe. So this, if you look at it, it can only give descriptions of the numerical variables. So things that have been converted to floats or ints, we can get some more detailed information. So this is very useful because when you're exploring the data, you want to know what the range and what kind of the typical or the average value is of each of your features. So that's what's happening here. So again, we have the count. So we can see that everything has no missing data except for the total bedrooms. Seems to be missing a few things, but we get some information about what the minimum and maximum value is. So like for example, the median. Let's look at the house value, since that's going to be the target that we want to look at. So this has an average of $206,000 in here, and we range from as low as just under $15,000 at the lowest end on this range, up to $500,000 at the high range on here. and we got the quartiles, 25th, 50%. So this should be the same as the median. So the 50th percentile is the median of these medians, the one value that's in the middle of all these. So. By the way, I have some kind of review notebooks. There's one on basic statistics that might be useful. So, if you're not too clear on means and medians and some other stuff like that, you might want to take a look at that. Although it also goes into distributions and stuff, which will be useful later on in this class. And there's lots of other things that you can do to explore your data better. So, just getting the numerical values of your ranges for all your, so the ranges of all your numerical values might not be enough for you to understand the distribution of that data, right? So here we're actually using what's known as a histogram to bin up the data, right? But this gives us a rough idea of the distribution of the data, right? So some of this data is a little bit bimodal. So like the longitude seems to have kind of two peaks in it, and the latitude. And if you read the discussion, if you know California, this corresponds to there's one population center up in the Bay Area, San Francisco area, and there's one down at Los Angeles, right? So these two peaks represent most of the counties are concentrated in those two areas. There's more counties in a particular longitude and latitude, so that's why this is bimodal here. But and some of these also, look like they're a little bit skewed, right? So they have a bit of a tail on some of these. And some of these, so this is discussed a little bit, but so we see something that looks like an anomaly. So these probably represent data that was being cut off, right? So there might be more than, so some median housing ages were bigger than 50, but whoever gathered this data didn't record anything bigger than 50. Anything bigger than 50 was just recorded as an age of 50 average for the house, right? So that's typical when you're seeing some kind of a cutoff on your data here. So that might be problematic, especially for our label here. But yeah, I mean, so there were some counties that had median house prices bigger than $500,000, but we only just cut that out. So we don't have that information really. So we artificially have a large number of them right at the $500,000 range here. Okay. So yeah, it is 9:15. I'll go ahead and stop there. This is a good point to stop at, and we'll pick this up on Thursday. So I'll talk some more. If you haven't looked at these notebooks yet, I encourage you to look at them yourself. Read the chapter 2. This should give you a good start on the second assignment. And I'll stop there. I'll begin talking in a little bit more detail about assignment 2 also on Thursday, as well as talk about this one and the next notebook, which is about cleaning, and a little bit more about the Scikit-learn framework. So. All right. Yep, that's it. Let me know if you guys have any questions here, final questions, or also for the live stream. Looked like the live stream was okay after we got past that first slowdown. All right. Yep. Thank you. I'll see you guys later. I'll see you guys next week, or Thursday, hopefully. So.